If you ask a person what time it is, they will tell you the day of the week, the month, and the hour. But if you ask a computer what time it is, it won't say Tuesday at 3 p.m. Instead, it will give you one single massive number, like 1.7 billion. To a computer, the concepts of months, leap years, and time zones are incredibly messy and confusing. To keep the internet running perfectly, machines had to invent their own way of tracking reality. Today, we are cracking the code on the hidden, beating heart of the digital world, Unix time. We are going to simplify exactly how computers count, the specific day the digital universe was born, and the terrifying mathematical bug that threatens to break it all in the year 2038. To understand how computers see time, we need to completely forget about calendars. We can break this down to a radically simple concept. Think of a giant stopwatch. When you start a stopwatch, it begins at 0 and simply counts the seconds. 1, 2, 3, 4. It never stops and it never resets. This is exactly what Unix time is. It is just a single, continuous count of every single second that has passed since the computer's stopwatch was clicked on. Whenever you send an email, post a picture, or buy something online, the computer secretly stamps that action with the exact number of seconds on the giant stopwatch. But if Unix time is just a giant stopwatch, when was the button pushed? When did the digital clock start at 0? In the early days of computing, programmers realized that if every computer started counting from a different day, the machines would never be able to talk to each other. They needed a shared birthday for the digital world. So they made an agreement. They decided that for all computers, time 0 would be exactly midnight on January 1st, 1970. This specific moment is known as the Unix epoch to a computer's core programming. The universe did not exist before 1970. However, building a stopwatch that counts forever requires an infinite amount of space, and old computers didn't have that. Imagine the mileage tracker on an old car. It only has enough physical spinning wheels to show up to 999,999 miles. If you drive one more mile, the wheels run out of space and physically roll backward to all zeros. When programmers built the original Unix clock, they only gave it a specific amount of digital space, known as 32 bits. This means the computer can only hold a number up to about 2.1 billion seconds. This mathematical limit created a massive ticking time bomb known as the year 2038 problem. On January 19, 2038, the giant stopwatch will hit 2.1 billion seconds. At that exact moment, older computer systems will run completely out of digital space. Just like the car's mileage tracker, the clock will roll over. But because of how the math works, it won't roll back to 0, it will roll back to a massive negative number. Old computers will suddenly think it is the year 1901, unless they are updated. This glitch could cause bank vaults to lock, GPS satellites to crash, and networks to fail. Here is a quick fact to wrap up the topic, because programmers love round numbers. The exact moment the giant Unix stopwatch hit 1 billion seconds was a major global event for nerds. It happened at exactly 1 hour 46 minutes and 40 seconds on September 9, 2001. This exact second in time was officially dubbed the Unix Millennium, and programmers all over the world threw massive tech parties to celebrate a number rolling over on a screen. Fortunately, we are already fixing the 2038 problem. Engineers are upgrading the digital world's stopwatch from 32-bit to a massive 64-bit system. By adding more digital space, the car's mileage tracker gets much, much longer. With a 64-bit clock, computers won't run out of seconds in the year 2038. In fact, this new stopwatch has so much room that it will be able to successfully count the seconds for the next 292 billion years. By simply giving computers a massive new box to drop their numbers into, we have ensured that the hidden clock of the internet will outlast the sun itself. Thank you for watching. We will see you in the next video.